Hello, everyone. I'm Quentin Anderson, and welcome back to Real Time Talk with Eagle 3D Streaming. Today's guest is Julian Crespi. And to briefly introduce Julian, he is a technologist at heart with a lifelong passion for 3D. After 17 years of experience leading animation and post production projects, he transitioned from advertising to the industrial world to develop digital twin applications using Unreal Engine and looking at new ways of mixing GIS and real time 3D applications. Now, at Ecodrones, he's in charge of leading his team of electrical engineers, data scientists, and land surveyors to help maintain the electrical grid through drone inspections and AI. How awesome is that? Julian, how are you doing today?
Hey, Quentin, great to be here. How are you?
I'm doing wonderful, and thank you so much for taking time out of your busy schedule to be on our podcast.
Yeah, sure. Thank you for having me. And that was quite a mouthful. A lot
Yes,
of
yes.
introduction.
Many things to talk about. Before we dive in, though, for any new viewers today, this is a live show. And this is all about you guys. And so please do not hesitate to ask any questions. We will try our best to give you solid answers. And with that, Julian, it'd be great to learn a little bit more about your interesting background. So, can you kind of walk us through how you transition from the world of advertising to the industrial world?
Yeah, for sure. So, yeah, like to quickly recap, I worked in 3D and animation from motion graphic studios for some 10 years, right, in Chile. And it was a great experience. We ended up working with big clients like HBO. So, like in fun facts, I ended up making a little teaser once for Game of Thrones. So that was like a like the height of my career.
Nice.
So that was interesting. And later on, because that was in Chile, and I came to Ecuador and I started my own animation studio, and I spent 7 years doing that. And it was interesting, but I always felt like the animation industry moved like in a very slow manner. Like, I don't know, like you have like iterative improvements, but it hasn't fundamentally changed the way that we have done things 17 years ago, right? We are still rendering, we are still going to After Effects, we are still using the same tools. It's quicker, it's faster, it's easier, but same tools, right? So it's not that huge innovation on that side. And then last year, I met the team at Automap Ecodrones, a company in Chile, and together we started researching about how we could mix the 3D world with drone data, right? So just to mention a little bit about Ecodrones. Ecodrones is a Chilean company. It's a company that works with drones, and we use those drones to inspect the entire electrical grid in Chile. And with that inspection, we have a group of electrical engineers that go over that data, that it's RGB data and LiDAR data, and they can understand where are problems in the grid, on the structures, on the cables, and also with the LiDAR data, they can understand where vegetation it's growing near the power lines, right? So yeah, that's Ecodrones, and we started to research what things could help in that area from the 3D world. And in that research, we understood the concept of digital twins. And for us, it was like opening Pandora's box, right? It was an amazing thing to discover. And when we started to understand what digital twins were about, for me, it was like instantly, right? When I understood the power of bringing 3D, real time, GIS data, IoT, everything fused together, like from my 17 years of perspective, from 3D, from a static point of view, right? It was static data, right? To have like an industrial use case with live data, for me it was like a mind blown moment. Like it was like, whoa, I see this is the future, right? Like no doubt about it.
So when we think about digital twins, what is the definition you like to generally offer as someone who asks you, "Hey, Julian, what's a digital twin?"
Yeah, so there are like many answers to that question. I think that the most basic one is it's to say digital twin. It's a digital representation of a place or a process from real life, right? So, for example, a digital twin. This is the easiest way I think. This is the easiest one is a factory, right? So if you have a factory in real life, you can scan that factory, have a 3D model of that, and have a 3D digital model of that, and start connecting different pieces of that model, like your, I don't know, like inspection line or whatever piece of equipment. You can connect that IoT data to your 3D model, right? So you have the real object in the factory, and you have the digital object with that data coming in, right? And you have like this digital visual representation of that object. And it starts to let you understand your data in a way that it was very hard for complex processes, right? So if you have a factory and you have too much machines, like no use. But if you have like 100 machines, right, all working together and everything is connected and there are a lot of relationships, that's a huge amount of data. And if you want to understand that data just by looking at dashboards, it's very hard, right? So a digital twin gives you a visual representation connected with that data to understand things in context. That's like the basic digital twin or the middle basic. And then the more advanced one is that if you have your factory, real factory, you have your digital factory, you can start doing things in the digital factory, like changing like how things are managed or worked or like looking for efficiencies in there. And when you get to the point that you're happy with the efficiency, you can apply that to your real factory, right? So it starts to talk like both ways. And also you can start doing predictions, right? If you have a lot of IoT data coming in and you have all the relationships built, you can start making predictions on what will happen on that factory, on your digital one and on your real one, right? So that's like a very higher level of a digital twin.
And do any examples come to mind of some sort of IoT prediction that you've used before in digital twins? Maybe like sensor data for temperature or parking spaces, or I mean, anything. Like, what example? Do you have any examples that come to mind?
Yeah, so for example, you could start predicting. I saw an example that I loved one time. It was from this company ANSYS, and they made digital twins for like heavy duty equipment. And they had this refinery like offshore, and they have a propeller below the refinery in the sand, and they could detect, for example, when that propeller, based on I don't know if it was pressure or something,
Hmm.
they could detect like when it was going to fail. But the really cool thing about having that in a digital twin model is that they could start predicting how to manage the efficiency output of that turbine so that it could reach its maintenance schedule, right?
Hmm.
Because if you don't have a digital twin model that will tell you it will fail, it will fail before maintenance, right? And if you have a basic digital twin, you can say, okay, it will fail. But if you have an advanced digital twin, you can say it will fail, but if you start lowering its output, you can maintain its operability till it reaches its maintenance cycle, right? So I thought that idea was like amazing. It's like you get the most out of it without breaking it and making it live through its maintenance cycle.
That's amazing. And why do we need a game engine to help visualize things in a digital format? Why can't we just use, Autodesk Maya and render some images and then render some more images?
Yeah, that's what the old me would have thought. Yeah, for sure. I think that's the groundbreaking ideas that they are not new, but that are starting to have traction. And what happens is that if you have a 3D model, for example, in Maya, you can't connect it to real life data, right? One. Two, you can't have a render in real time inside of Maya. You could argue that there are like real time render engines like Redshift, that could render in real time, right? But it's not there. And also you would have to be a very experienced technical user of Maya to be able to interact with that data, right? So the tools are not there, and you would have to have a lot of knowledge to interact with that data, right? And a game engine, what brings to the table, it's the ease of use and the huge, but huge rendering capabilities, right? So you can grab a very complex data set, let's say a factory. You can grab that data set, load it into Unreal Engine, and have it displayed with really high quality graphics, right? Which are very important for people to understand context and perceive a sense of reality from an object, and especially to convey information to non-technical users. So what happens usually is that this idea of digital twin, it's when you hear the idea of digital twins, you hear the idea of data living in silos, right? So very data living apart, very difficult to access. But usually that data is thought as PDFs, Excels, CSV files, whatever, right? But it's like 2D formats, right? But there's a lot of data companies handle that it's in 3D. So LiDAR point clouds, AutoCAD data, right? Reality captures. You have a lot of different types of 3D data, and all of those types of data are very technical. So it's very hard to access them. So if you want to handle a point cloud, you need specific software, and you need a specific understanding of what LiDAR data is. It's not that easy to use at first, right? Then you have AutoCAD files. You need to understand AutoCAD or Revit or whatever application, Rhino, whatever. So a lot of technical knowledge, right? And if you are a decision maker, it's not in your interest to have that technical knowledge. You want to make a decision, not understand how to use AutoCAD. So in that sense, what Unreal brings to the table is the ability to integrate all of these types of data, right? So you can bring in AutoCAD files, you can bring in LiDAR point clouds, you can bring spreadsheets. You can mix the 2D with the 3D and have all of this live in a very high fidelity visualization, and the ability to connect all of that to APIs. So you can connect everything in here to data outside the application, right? So it's like it works as a website, so to speak. So you can connect to a weather website, and you can grab that data and put that weather into your application. If you have IoT devices, you can connect to your IoT devices and bring that data into Unreal, and you have then this aggregator of different applications and data sources, right? And have everything live together, and you can interact with that in a very easy way, as if it was a game. But the data behind it is highly technical.
Yeah, and could you almost argue that one of the applications is sort of like a 3D data visualization toolkit? I mean, there are other applications, but maybe that's one benefit of using a game engine in that sense.
Yeah, exactly. So, for example, what's really interesting about that idea that we've talked a lot inside the company, it's we have tools for visualization, right? But all of those tools usually they have a ceiling, right? Like, what can you do with that tool? And then what happens if you want to make that tool connect to the data from this tool? You can't, right? And Unreal, because it's Unreal, it has like huge amounts of interoperability, right? So you have things like Datasmith. It's an SDK that the people at Epic Games have developed, that it enables you to load data from 3ds Max, Maya, AutoCAD, Rhino. So huge different types of data sources. You can bring everything together and have it all, I don't know, like maintain the integrity of the information, because that's one very important thing. Your data lives in an isolated place that only that tool where it was created can understand that type of data. So if you want to move that to another application, that application won't understand that data. And Datasmith in Unreal, what does, it converts that into Unreal Engine so that you can preserve your original information.
Yeah, and it would be interesting to explore that in the context of what you're doing right now in Chile with the electrical grid project. So, and correct me if I'm wrong, did you survey a large portion of Chile to get 3D spatial information? Or,
Yeah,
yeah. So, how did you get that data and import it into Unreal?
yeah, I can show you.
Oh, cool.
Yeah. So it's not about like making a very technical demonstration of what we can do. I want to show more of the results.
Cool.
But to give an example, for example, I don't know if you can see this.
Yes, yes, it's now on the screen.
Yeah. Right. So this is like this is the combination of the idea that made me change industries and projects and leave my own company behind and start working with the amazing team at Ecodrones.
Mm-hmm.
And we started building this application, right? What you are looking at here, this is a LiDAR point cloud file, right? And for people that don't know what a LiDAR point cloud is, it's LiDAR, it's the light ranging and sensor, I think it is. I never can remember the specific meaning of the word.
Mm-hmm.
But LiDAR, what it does, it's a sensor, like an infrared sensor, that it emits a pulse of light. That pulse of light travels and it hits something. And when it hits something, it bounces back. And the time it took from going and coming back, it's the distance of that point,
Mm-hmm.
right? And now imagine millions of points being emitted every second, like
Mm-hmm.
bah, bah, bah. And all of these points bouncing off of every surface gets what's really amazing is that they get correctly measured. So you can take measurements by centimeters. You can say like I don't know, like measurements like with a 5 centimeter accuracy. Like so that's huge in the context of the really big area that you can acquire, right? So what we do is that we go with our sensors in vehicles or in drones and we scan a very large part of area. And with that scan, this is what we get. And you can see if I get really close, you can see points. That is why it's
Yes.
called a point cloud, right?
Yes.
What's really cool is that all of these points they have like the RGB data. They have the color of the
Right.
point where the pulse of light hits, right?
Mm-hmm.
So you can get like this really nice render. And what we do is we get that LiDAR point cloud, and we can identify different aspects like the towers, the trees, and for example, here you can get a tower, for example. And we identify this, and using like very technical tools, we can identify the trees, classify everything based in their category, and then we can start saying like, okay, how close are the trees near to the power line, right? Because you have like this safety buffer
Mm-hmm.
for trees getting near the power lines, and the electrical companies need to cut that in case they get too near, right? So we are always looking at ways that we can improve how we can tell our customers like, hey, you have these trees that are getting too close to the power lines, right? And what you're seeing here, like at this stage, nothing new, right?
Mm-hmm.
And what's interesting is that we were talking about the idea of the maturity level of a digital twin, right?
Yes.
So when we talk about a digital twin, and I made the example of the factory connected to the IoT devices, and then you can start having predictions, like that's a very advanced digital twin, right?
Mm-hmm.
And we would say that that is like a level 4 or level 5 digital twin. But you
Mm-hmm.
can go back and you can say, look, okay, what's the simplest form of a digital twin? And many people argue for a digital twin, you have to have a live connection to something in real life, right? But there are other people who argue that no, a digital twin can be as basic as basic because it's hard to get this, as basic as a 3D point cloud, for example, or a 3D reality capture,
Mm-hmm.
right? So
Mm-hmm.
this could be a digital twin level 1, for example, right? So a digital twin level 2 could be having 3D data, for example, this you could have like 3D data of your asset from your life. You can
Mm-hmm.
see this is no longer a point cloud. This is a 3D object, right? And
Yes.
we can have this 3D object with BIM data. right? So if you can have now you have a visual representation of something in real life, but you also have data from that object, right? And you can have metadata from that object,
Perfect.
right? And metadata can be anything, and with any level of accuracy that you want, right? You want to know the idea of the bulb, you can have that. You don't want that, you want only the idea of the tower, you can have that level, right? So it really depends on what you want, what you have available, right? So this would be like imagine a factory place with all of these 3D objects, all of them with their own custom BIM data. That would be level 2.
Perfect.
Right? And I think that what's really cool is that you can go higher in level 2 and start adding different types of data. For example, here we added satellite data, right? And you can see the point cloud matches the road from the satellite imagery.
Mm-hmm.
And what's really cool is that this is happening because everything is living on a geo-referenced place. So this will be a bit of a tangent, but the idea is that data in the real world is geo-referenced. You have GPS, right? GPS data. And 3D data usually doesn't have 3D data usually doesn't have a coordinate system based in GPS data,
Mm-hmm.
right? So Unreal Engine, for example, 2 years ago, we wasn't able to handle like GPS coordinates, right? And now you can have these GPS coordinates that allow you to locate objects from the real world in this digital space correctly, right?
Amazing.
So we don't put this point cloud by hand in that place. We use its coordinates with the coordinates of the satellite imagery. We match that and everything matches. And for me, that was like really we can grab like 3D data and position that in GPS space and have it match a satellite image. Like, I don't know. For me, it was like too much.
That's
Okay.
yeah, it's amazing.
So,
Well, and you know, just to give an example of that, so you know, we have basically latitude and longitude being in the real world being mirrored into the 3D into this digital world is one example. So if we're tracking something, the latitude and longitude of an object, we can send that information into the digital twin and it will update accurately in the exact same position.
exactly. That's the real cool thing. About you have like use this, and we can have like elevation data, right? So elevation data, it's not very accurate, but if you have latitude and longitude, you could place it on top of the mountain, and you can see it like climbing the mountain, right? So what's really cool is that it doesn't live only in a flat 2D space, right? You're getting like this very complex height information from the real world. Okay, let me go back here. Okay, so this would be like a level 2 digital twin, right? So 3D, different types of 3D data, point cloud, satellite. You can see on the back like very simple representations of buildings, which also are very accurate, right? So if you knew Chile and you look at this place, it's very famous. This is like the highest building in Latin America, right? So the really cool thing is that the data it's from OpenStreetMaps, for example, and ideally it's correct, the data. So also that you can get like all this 3D building data and have it match the satellite data and the georeference space, and have that live with your BIM data, so with the point cloud data. Sorry, I lost my. There it is. There it is. Yeah, with your point cloud data. Yeah.
And we had a question come in for you, and the question is, could we import Google Map images into the game engine?
Yeah, so for example, you can import any type of world street mapping, right? So if you can get Google data from in a WSSM format, you could, right? I don't know really if Google exports that in that format. The satellite imagery it's coming from Bing, right? So this is like a Bing satellite imagery, right? But yeah, if you can get a link to the WSM from Google Maps, you could be able to import that into Unreal.
Got it. So as long as you have that file format, then yes, you could import Google Images into your Unreal Engine
Yeah.
application.
Yeah, because the interesting thing is that it's to talk about 3D tiles as a format.
Mm-hmm.
So 3D tiles, they are like this amazing format that was the like the unlocker of everything that we are seeing here, especially regarding the satellite imagery, in the sense that it was impossible to have like this scale of information inside Unreal Engine, right? Like if you thought about it, all of that you're seeing like as a true 3D mesh that has all that data and all that texture, and Unreal would, I don't know, explode,
Mm-hmm.
right? So 3D streaming, it's the idea that you can get like 3D tiles, and those tiles are like just blocks that can load different types of data on top of those blocks, right? So you're streaming the satellite imagery, you're streaming the elevation data, you're streaming the geometry. So almost all of this data lives outside Unreal. That's what it allows it to have these huge data sets being loaded by the application, right? Yeah, and just to end this, this is still static, right? But what we were thinking about was the idea that we can see, for example, painted in color, we can see the trees that are near the power line, and you can see like different colors, right? For those trees based on how close they are to the power line, right? And we started to ask like, hey, what if we could apply the weather condition to understand how trees would move with the wind, and how would that impact their proximity risk, right? And if you look up here, you are seeing like different weather conditions, like the temperature, wind speed, UV index. This is this is real data, like 40% clouds. This is real world data being streamed into Unreal Engine based on the location of the point cloud. And all of that is automated, right? Like I never say like, hey, we are in Santiago. Like everything is done automatically, right? Also, we can load point clouds on demand. Like you give us a point cloud, and we can load that and have it geo-referenced and have the weather and all that data, like everything linked automatically, right? Okay, so we get that data, and then I say, let's simulate, right? So now what it's doing, you can see the clouds changing. It's looking at the forecast for this specific location for 8 days in advance, right? Maybe it's debugging. Oh, there it is. This is very alpha stage.
Very
So
cool.
sorry if it crashes. Yeah. So what it did, it was like, hey, what's the weather conditions for this specific location for the whole week, right? And apply that weather wind speed and wind direction to the trees, and see how the trees will bend and how will they impact the cables. And we saw that we got a max wind speed of 22 kilometers. We can see the wind speed per day in the coming days, the vegetation risk based on proximity, like the imminent risk per day, which is trees contacting directly with the conductors, and a risk priority that tells us, hey, your risk is very low, right? With this type of weather, nothing will happen, right? It's low. You have only a 18% wind speed, but we can like take things a bit further. Let me see if this works. Yeah, it works. Yeah. So now I'm making the trees grow. Let me see if yeah. I can make the trees grow based on different aspects, because the trees also have their own metadata, right?
Mm-hmm.
So the trees have the species, their age, height, diameter, latitude and longitude, right? The inspection date. We have all that information for every tree, and then we can make it grow. And now that they are taller, we can also multiply the wind speed a little bit, so that when I simulate now again, local, ideally we will get much more higher risks based on these new simulation conditions, right?
That's amazing.
So what's really cool is let's say a storm is coming, right? A storm is coming and you didn't cut the trees, or you're in a location that you have like higher, like more grown trees, right? Now you will get 7 imminent risk trees. So you got like 7 trees. This one marked here. These trees hit the line, right?
Mm-hmm.
With the conductor, with that growth and that new wind speeds, right? Like wind speeds of 140 kilometers, like really high wind speeds, right? you got all of these new types of trees. Right. So what's cool about this is that it's bringing, you could say it's like IoT data, like weather data. So we're bringing data from an outside source, and we're getting a prediction of that data, like the weather prediction, and using that to predict how trees would behave in this particular scenario, and give you an insight about that.
Yeah, and I just want to say like how mind blowing that is. I mean, you are literally taking actual weather forecast patterns and predicting whether or not there is going to be any issues with existing power lines in this real world area. Like that is amazing. And I know we're kind of running short on time. Thank you so much, Julian, for this overview. We're getting a lot of cool comments coming in from everybody.
Really?
Yep. So that's
Awesome.
amazing. So, well, we have one more question for you, if you don't mind, and then maybe we can just I'll ask you a question. You know, how does pixel streaming fit into all this? Because we are a pixel streaming
Yeah, for
show.
sure. Yeah, let's do it.
And then maybe we can sign off. So the question is: so with NERF point cloud data, you infer height and assess weather risks to power. That would head off power outages and maintain city. Okay, so it's more of a comment, or just to clarify. So with NERF point cloud data, you infer height and assess weather risks to power. Is that correct?
Yeah, so we get all the XYZ data, right? So we get latitude and longitude and height, right? And what you saw with the trees, you saw a 3D visual representation of the tree based on the tree that we got from the LiDAR point cloud, right?
Mm-hmm.
So we get the height and the diameter of the tree. We get our 3D tree in there, and that's what we simulate. But it's based on the real initial conditions of the tree that we captured.
Amazing, amazing. And yep, and I know we're kind of running out of time, but so how does
Yeah,
pixel
so
streaming fit into
it's
all of this?
amazing. No, pixel streaming for us, it was a huge piece of the puzzle, because we have an online web platform where we do like a GIS web platform where we do all of our analysis, right? We load the LiDAR point clouds, we load the images, thermographies, everything over a map, and we can make all the analysis in there, right? And that's like 5 years in development. So it's a very robust platform. And when we started thinking about making these applications, we didn't want to make it like a separate thing from our main service. So it was crucial for us to be able to integrate this application into our web platform. And the way to do that was, for us, it was with pixel streaming, right? And in that sense, that's why we approached Quentin and Eagle, in the sense that, hey, we need to make this. Can you help us? And they were great, helping us in a way that very, very easily we can upload our application into the platform and get a link, like an iframe link, that we can put into our web platform and have all of this embedded in a website. I think that, let me see if I have a really quick automat. 1 second, please. Let's see if I have a link for this. Yeah, I have it. Awesome. I don't know if I can show it, maybe.
Sure. Feel free to bring it up.
I don't know if
And while you are, we had another comment come in. It said that would head off power outages and make the city maintainable. Wow, well done.
Yeah, awesome. Thank you. Yeah, I think it's like the hardest part is getting the actual information about the trees to make it like very like the information that we can get to be very like accurate, right?
Mm-hmm.
So it's, if you have the correct data, that's great because you can make it work. It's very hard to get that data, but if you have it, you can have like some amazing results. And in this sense, this is hard because of the organic nature of nature. Sorry. But if you are working with machines, factories, anything that's like, I don't know, like man-made, it's much easier to have an idea. Maybe this is an older version, but what you're looking here, it's just the iframe that it's here. Yeah, it's an old, yeah, it's an old version. I don't think it will load. Sorry. Yeah, let me stop sharing. But the cool thing is that you can have like a website and have this embedded on that website, right? And what's really cool is that you can give it parameters, right? So for us, it was amazing that we can pass it information from our website, from our web platform, for it to load. So this scene that you saw, this is one scene of, I don't know, like 1,000 possible scenes, right? So we can load our 1,000 platforms, 1,000 pointers that we have, and it will load correctly for each location with its all of their information dynamically. And that's also because of the integration we have with Eagle, that we can pass it parameters and it will load with those parameters and show you that inside your website. Yeah, so for us it was like a crucial piece of the puzzle to be able to load this into Unreal. And just to end that thought, the other thing is that we have other clients in the Middle East that we need to interact with, right? And we're building some smart city projects. And what's interesting is that for us to send them an Unreal Engine project, it's just too heavy. And also it's like, it's hard to ask for your client for them to have a very high quality machine that they can run an Unreal application in, right? So what Eagle allows us is to, hey, we are making some changes. Here's the link. Check it out, right? So very fast iteration because we just upload it and they like consume it almost as a video, right? It's like, okay, here's the link. I get in and I watch it and I can use it, right? So that type of really fast iteration and lowering the, I don't know, the usage barrier, I think for us it was also very great.
Yeah, it makes, I guess, sharing easier for your application.
Exactly, for sure.
Wonderful. I mean, thank you so much, Julian, for sharing all the cool things that you and your company are working on, and congratulations on all the innovations that you're adding to this space. For anyone who's interested to follow up with you, best way, website, LinkedIn, email?
Yeah, sure. In LinkedIn, I'm very active in LinkedIn. I don't know if also my email is going around there, but if you search me like Julian Crespi in LinkedIn, it's very easy to reach me. I'm very passionate about this, so I'm really very open to talk whenever anyone wants, like sharing this. And also just a huge shout to David Weir McCall from Epic Games, because he was like huge support for us, right? From the beginning. He saw the idea, he was a believer, he helped us a lot with this project, and all the people at Epic, like really, it's an amazing company to also to work with. Yeah, like outstanding.
Awesome. Yeah, they're great guys and girls. Thank you so much, Julian, for stopping by today. I am Quentin Anderson. This is Real Time Talk with Eagle 3D Streaming, and we will catch you on the next show. Thank you all for joining.